Okay, so just a reminder from yesterday, we are rotating conics. So if we have an equation where there's maybe an x squared and or a y squared term with maybe an x and a y and a constant term, like you did on your quiz yesterday, we could complete the square and rearrange until we have a standard form of either a parabola, circle, ellipse, or hyperbola. Okay? When we have it in this form with no bxy term, we can tell without any math what kind it's going to be based on A and C. Okay? If there is a bxy term, then we're going to have some sort of rotated conic. Okay? So we are going to determine the angle at which this conic is going to be rotated. And based on that angle, we are going to figure out the standard form equation of our new set of axes. Okay? So this right here, we're going to call, let me do a different color so it stands out. Like x prime and y prime. Okay, and we're going to define a new set of axes and make a standard form equation that we would put on the x prime and y prime axes and put our graph that way. Okay, we can graph horizontal and we can graph vertical. So if we define a new set of axes based on that rotation, then we can graph there either horizontally or vertically. Okay, so yesterday we went through how to identify the type of conic that we have. That has to be your first step, okay? You need to know what type of conic it is so that you can put it into standard form, okay? Yesterday when you were taking your quiz, you had 3 non-rotated conics to put in standard form. If you didn't think about what kind of conic that was to begin with, it made it a little bit difficult to rearrange your algebra, okay? So I always identify what kind of conic we are talking about first. Okay. What we are going to do is we are going to take an equation that looks like this, and we are going to rewrite it in terms of x primes and y primes. And like I said on the slide previous, the x primes and the y primes are going to be for our rotated axes.
Is this hard or is it just a little work?
There is a lot of work involved, okay? It's a lot of algebra, like distributing and combining like terms and things like that. Yes. Okay. Some room for mistakes, which means taking our time would be a good idea. Okay, well, what are these x primes and y primes? We can't just like magically change them all. Okay, it is a 2-step process in order to figure out what x prime and y prime will be. Okay, the first thing we have to do is figure out what angle we are rotating this conic by. And we're going to do that using one of these. They mean the same thing because cotangent and tangent are reciprocals of each other. So if you like tangent better, write this one down. If you like cotangent better, write the other one down. Okay? But using our coefficients A, B, and C from our general form, we are going to figure out what theta is by taking the tangent of 2 theta equal to B over A minus C. More than likely, it'll be a number like radical 3 or 1.
Which one do you recommend that we use?
Really, it doesn't matter. It's more about what you feel more comfortable thinking about from the unit circle. Do you feel comfortable thinking about tangent from our unit circle or cotangent? Okay. I think for most of us would feel comfortable with tangent, but I don't want to pressure you into anything that you don't want to do. I'll let you pick. Okay. Now, that angle is going to tell us how far we're going to rotate our axes counterclockwise. Okay, that's how we rotate in math, right? Counterclockwise. It'll also tell us how to determine x prime and y prime. Okay. So once you have theta, you are going to rewrite x and y using these two formulas right here. So we really haven't even started the biggest chunk of the problem yet. And there's already quite a few points you would be awarded in the problem. So I'm going to look for you identifying the type of conic, you identifying the angle using that formula, and I'm going to give you points for rewriting x and y. Okay? Then what we are going to do with these right here, we'll reduce them because we're going to have a nice unit circle angle. So we can take the cosine of theta and the sine of theta and actually write those as coefficients for those x primes and y primes. And what's going to happen is we're going to come up here to this equation. All of the x's get replaced and all of the y's will get replaced using this right here. So then we're going to have binomials that we're going to have to multiply and combine like terms. And what's going to happen every time is that we're going to have an xy term to begin with. But once we make those substitutions, notice how there is no longer an xy term. So then we can actually complete the square and get it into standard form. Okay, this xy term is causing us a problem because we can't factor with it because it has an x and a y. So by doing this trigonometry right here and making these substitutions, we will have a general form equation that we can complete the square and do our factoring and get a nice equation. Okay, yes, it's going to take some work, but it will be fine. Okay? We have trained for problems like this. Okay? Now, just because it's been a while, I am going to remind you about our unit circle. What's the coordinate right here? Which means the cosine of 0 is 1 and the sine of 0 is 0. Up here, the cosine of 90 degrees is 0, and the sine of 90 degrees is 1. Okay? Pi over 4. Pi over 6. And pi over 3. Okay? Don't forget those coordinates. You're going to need them. Okay? All right. So we're going to do a simple problem together. It's one that does not require as much algebra as the second one we're going to do. But I want to start simple so you can see the process. And then we're going to go through number 19 from your homework step by step together. Okay? So write down this conic. And at your table, I want you to determine what kind of conic it is by using the discriminant. Use a discriminant to figure out what kind of conic this is.
I'm not getting that. So it would be a hyperbola.
Okay, Emily. Okay, Emily.
Is that loud?
Yeah.
Oh.
All right, we all heard Emily say it's a hyperbola. Emily, how did you get that it's a hyperbola?
I did 1 squared minus 4 times 0 times 0.
Okay, and that is bigger than 0, so we have a hyperbola. Okay, a is the coefficient of x squared, c is the coefficient of y squared, and so since we don't have those, they're zeros. Okay, b is the coefficient of xy, so b squared minus 4ac. Okay. The next order of business is taking our equation, the tangent of 2 theta equals b over a minus c, and figuring out what our angle is there. Okay. Well, you told me b was 1 and a and c were 0.
Undefined.
Ah, do we have a time where the tangent is undefined?
90.
At 90 degrees. So we have that the tangent of 2 theta is undefined. Well, that happens at pi over 2. But our angle is 2 theta in that equation. So we're going to say that 2 theta is pi over 2, which means theta is really pi over 4.
Seriously.
Okay. Now, we need to determine our substitutions for x and y. Okay? Our substitution for x is x prime times the cosine of theta minus y prime times the sine of theta. And since theta is pi over 4, I'm going to put in pi over 4. Okay. Well, can we determine the cosine of pi over 4? It's radical 2 over 2. And can we determine the sine of pi over 4? It's also radical 2 over 2. So here's our substitution for x. Okay. Our substitution for y is x prime sine of theta plus y prime cosine theta. So notice how the sine and cosine flip-flop, and x has a subtraction, y has addition. Okay, so their formulas are pretty close to each other. Okay, all right, so our y substitution is going to reduce to radical 2 over 2 x prime plus radical 2 over 2 y prime. Okay, 4 points right there on a test question.
Just that?
Mm-hmm.
Plus everything else, or just that?
1,
Oh.
2, 3, 4.
Well, I think my 4 points just red.
Okay.
Okay.
Now, what do we get to do with it? Okay,
Plug it in.
that is right. So I know that it's kind of covered right now, so I'll rewrite it. So our original problem is xy minus 4 equals 0. Okay, and this xy is the problem. Okay, so by making these substitutions, our xy should disappear, and we should only be left with x prime squareds, y primes, and y prime squareds. Okay, so x, we determined was radical 2 over 2 x prime minus radical 2 over 2 y prime. That was x. Times y. And they're being multiplied, so I'm going to write them in parentheses so we can multiply them. Y is radical 2 over 2 x prime plus radical 2 over 2 y prime. Minus 4 equals 0. Okay. Now we need to actually multiply everything out. Okay. Now in this case, we only have two binomials to multiply to each other, so that's pretty nice. Okay. Radical 2 over 2 x prime times radical 2 over 2 x prime. 1/2 x prime squared. Radical 2 over 2 x prime times radical 2 over 2 y prime. 1/2 x prime y prime. Well, if I'm doing the outside, it would be positive. But then when we do the inside one, this product is negative.
Oh, I negated that last one. Because they cancel out.
Yes. We do have conjugates, so you're right. Those are going to cancel out, which we expect the xy terms to go away, so that is good that we got those to cancel out. And then our last product, negative radical 2 over 2 y prime times positive radical 2 over 2 y prime, would be minus 1/2 y prime squared. Okay. Now, this is where the algebra gets kind of crazy. Right now, we only had an xy term, okay? You could have an equation that has an x squared, an xy, a y squared, an x, and a y, where we would have to multiply all of that out. And that's where we're going to have to bring our patience. Okay?
Man.
So now, what did we have? A hyperbola?
Yeah.
Okay. So I have 1/2 x prime squared minus 1/2 y prime squared. I'm going to go ahead and move the 4 over. Are we in need of completing the square? No, because there is not an x prime and there is not a y prime. Okay, if there were an x prime term, we would have to complete the square, but there's not. So all we have to do in order to make this look like a parabola, we got to divide by that 4. So we have x prime squared over 8 minus y prime squared over 8 equals 1. Okay. Before we get into the one homework problem we're going to do as a class, what questions do you want to ask me? Ask me. So tomorrow we'll graph them. Today I just want you to stop here. Okay? Because I don't want to overwhelm you. Okay, so we'll graph them tomorrow. What else? Okay. What's going to happen is we have a horizontal hyperbola on the x prime axis, and we'll talk about all of that tomorrow. Okay? So if you look at your homework, there are 4 problems, correct? Who has their gold sheet out? Okay, what are the 4 problems? 13, 17, 19, and 22. We're going to do number 19 together. And number 19 is this. So go ahead and write it down, number 19. This one looks a little bit different, doesn't it?
Yeah, it looks a lot.
Okay, there are more terms in this one. Okay? But I do notice that there's an xy term, which means we have a rotated conic. Okay? If there were not an xy term, this would be simple. Like what we did on our past two quizzes. Okay? What I'd like you to do at your pods, work together to determine the type and determine the angle. And then stop. Determine the type, determine the angle. Show your work for both.
My work is.
What? 36 times 3.
Nope. Minus 4.
This one's in our work. It's in the That's what I thought.
I'm going to turn on the light.
Oh no, maybe Did you get 13 minus 7? So don't 6 this can't out and just get back from 3. So then since it's 2. Oh, right. That's dumb. Yes, the last 5 or 6? Or no, 5 or 3. Thanks. Okay. So 5 or 6. Hold on. Okay, so that would be.
Okay, figure out the angle. Okay.
And then y divided by x. So you do. You have to do the x. So and then that is so much work.
X prime.
I see some of you pulling out your calculators. I just want to remind you that you won't have your calculators on the test. Okay? So I don't mind if you use them now, but you won't get to, so you may want to practice.
Well, like, because you get the
yeah,
answer,
but
it'd be like
You know
the
that 4
tangent
times
to
13
theta
is going to be
equals
bigger than 1
radical
away.
3. And so then you have to find like the radian form of radical 3, tangent of radical 3, and then you divide it.
Well, 4 times.
That's tangent 2. So
Sorry, that's what I meant. 13 times 7. And then times 4. So you have 28 times 13. That's going to be bigger than 1. You see what I mean?
Yes.
Okay.
Did you go to where it
Okay, so the type of conic that we have. Sydney, what type of conic is it? Circle or ellipse? If you take b squared minus 4ac, and this is where I saw some people getting their calculators out. Okay, 6 squared is 36, radical 3 squared is 3, so you have 36 times 3. Here you have 4 times 13 times 7. Without a calculator, I think we can figure out that 4 times 13 times 7 is going to be bigger than 108, which is making this negative. Okay? You don't have to know what it is, you just need to know if it's negative or positive. or 0. Okay? When we set up our equation, tangent of 2 theta, what did you set up on the right side, Aaliyah? What did you set up over here? Okay, and that reduces to radical 3, right? Well, where is the tangent equal to radical 3? Yell it out. Pi over 3. So if 2 theta is pi over 3, then theta is pi over 6. Okay? So now take some time and determine what your x and y substitutions are going to be. Probably not.
No.
Probably not.
Oh, I might be gone for too. Whatever.
Okay, so if x is x prime cosine theta minus y prime sine theta, then you should have radical 3 over 2 x prime minus 1/2 y prime. And if y is x prime sine of theta plus y prime cosine of theta, then y should be 1/2 x prime plus radical 3 over 2 y prime. Is that what you have written down on your paper? Do you have a question on how I got those numbers? Okay, so this is where the fun begins. I'm going to rewrite it so we can all see it. We have 13x squared plus 6 radical 3xy plus 7y squared minus 16 equals 0. And we need to make substitutions. Okay, so this is what we are going to do. 13 times x squared. What's x? X is radical 3 over 2 x prime minus 1/2 y prime. So there's 13x squared. Plus 6 radical 3 xy. So we're going to rewrite x. We're going to rewrite y. Be careful. Write the right number. Write the right positive or negative. Write the right x prime or y prime. Okay? Then we have plus 7y squared. So I'm going to replace y and it's squared. Okay, when you have this written down, drop your pencil, look up here.
Oh.
Okay, like Max said, there is room for error. So pay attention to what you're writing down. You write something down wrong here, and it screws up all of your math. Okay? I'm not trying to scare you, I'm just trying to make you aware, okay, of the things that could happen. Okay? We replace all of our x's and y's. Now, what do we have to do with all this? We have to multiply it all out. And our goal is that by the end, what's going to happen? The xy terms will not be there. So this is what I want you to do first. We're going to do this step by step to make sure we're not making a mistake. I want you to take this right here. You're going to write 13, and then you're going to write the FOIL of that here. Right? We have to FOIL this because it's squared by, it's a binomial times a binomial. Then, plus 6 radical 3. Whatever this is right here, you're going to write here. And then plus 7, whatever this is, you're going to write here. And then we'll just go ahead and move that 16 over. Okay? So, I'm going to give you a couple minutes. You need to do 3 different FOILs for me.
Right.
Be careful. Yes, you can. Yes, you do.
It's okay.
You can do it. If you need to rewrite that as radical 3x prime minus 1 half y prime times radical 3x over 2x prime minus 1 half y prime, if you need to write both of them to FOIL, that's fine. But you got to FOIL. And when you're done with filling in those 3 blanks, stop. I don't want you to keep going if you have a mistake.
No, that'd be so unfortunate. But it'd be fine.
You have to FOIL this. This is, yep, there should be 3 terms.
Oh, because I didn't do the middle.
Yeah, you didn't do the middle 2. Okay, and the same thing with the blue. Those aren't conjugates. Okay. You have 0 conjugates in this one.
Oh.
The blues aren't conjugates because their numbers change.
Do you have one?
Like the middle school line.
Nope.
No, because it's not.
Nope, because it's the same thing. Okay, there are 0 conjugates here, so you're going to have FOIL for all of them. If you need to go to 2 lines, it's okay. We'll follow it.
Very annoying. Is it really? I don't think so.
Okay, look up here, ladies and gentlemen. We're going to do the red together.
But that's the one I just did.
Well, let's check it then, guy. If you've done it, that's fine. So the red. This is technically what we have. Right? Okay. So our first product, radical 3 halves x prime, radical 3 halves x prime, is 3/4 x prime squared. Our outside product would be negative radical 3/4 x prime y prime. Our inside product, negative 1/2 times radical 3/2 would be negative radical 3/4 x prime y prime. And then our last product, negative 1/2 y times negative 1/2 y, would be positive 1/4 y prime squared.
That's like an entire line.
That's okay if it take as many lines as you need to. Okay? Yeah.
Seriously.
Since there's two negative.
Yes. Yes. Max is asking, can we write this as 3/4 x prime squared minus 2 radical 3/4 x prime y prime plus 1/4 y prime squared? The answer is yes. These two we can combine together.
And could it just be
Can you cancel it?
radical 3/2?
Yes, it can. I'm going to leave it as denominators of 4 so that all of my denominators are the same. Because eventually we're going to have to combine like terms. Okay, so now that's what you need to do for the blue. That's what you need to do for the green. Okay? Compare products as you go. I have no problem with that. Go to a second or third line if you need to. Just stay organized.
What did you guys get for the product of the middle? Mine's what? 4/4. I love this. I got 3/4.
Yes. Because I got negative 1/4 x prime y prime plus 2/4 x prime y prime. Oh, plus
Just
And then
put the parentheses with x prime. I have the 1/4. Like that 1/4 doesn't have a square.
It does have to be.
The x prime has a square. Yeah, if you want to use 3 different lines for the 3 different products, just stay organized so I can follow your work. I'll give you about 2 more minutes.
the last one. 1/4 x prime squared plus 2 radical 3/4 x prime y prime.
Okay, I'm going to go through all 4 products and then we'll combine the middle 2 terms as a second step. Some of you might combine the 2 middle terms in your work and I am perfectly fine with that, but I just want to make sure that I'm not overlooking anybody's work, okay? So if we FOIL here, our first product is radical 3/4 x prime squared. Our outside product is 3/4 x prime y prime. Our inside product is -4 x prime y prime. And our last product is negative radical 3/4 y prime squared. Which means if you combine like terms, you would have radical 3/4 x prime squared plus 2/4 x prime y prime minus radical 3/4 y prime squared. Okay, I know that that's 1/2, but everything else has a 4, so I'm just going to keep it that way. Okay, then here in green, our first product should be 1/4 x prime squared. Our outside product would be radical 3/4 x prime y prime. Our inside product is also radical 3/4 x prime y prime. And our last product would be 3/4 y prime squared. So if we combine our two middle terms, we have 1/4 x prime squared plus 2 radical 3/4 x prime y prime plus 3/4 y prime squared equals 16. Okay. Well, because I don't have the room that you guys have. And I would do this on the board, but I'm recording. And I want people who aren't here to be able to experience all of this. I only think that's fair. Okay. So now what are we going to have to do? Distribute. 39/4 x prime squared minus 13 times 2 is 26 radical 3/4 x prime y prime plus 13/4 y prime squared plus 18/4 x prime squared plus 18 radical 3/4 x prime y prime. Nope, that's 12. That's a 12. Minus 18/4 y prime squared plus 7/4 x prime squared plus 14 radical 3/4 x prime y prime plus 21/4 y prime squared equals 16. You ready for the magic?
No.
Oh my god, that's the second term. Oh, it's
All of our xy's. What do they add up to be?
0.
Are you kidding?
Can I just assume and it's not?
You want to double check. But then, will you just believe me that this happens? All of the x squareds add up to 16, and all of the y squareds add up to 4.
I believe you.
Yeah.
Not doing
Well,
I don't know about that. I think we should do it.
You can check it. But I know the bell's going to ring.
Go ahead, Mary Kay, go check it on the board.
So if you combine all of the like terms, they add up to be that,
oh, yeah.
and we have an ellipse.
You divide by 16.
X prime squared plus y prime squared over 4 equals 1.
Whoa.
Oh, thank God it's over.
30 minutes.
You have 3 of these problems, and I will tell you number 13 is very similar to the first one we did, so it's shorter. And then 15 and 22 are more like that.
Oh my god.
There is a lot of work, but guess what? If you don't practice it, that's like a lot of points you're not getting on your test. So, you have 3 problems.